So we'll come to question number 26. In question number 26, it is a single. This section contains 5 questions. The single integer from 0 to 9, both inclusive, and it is a single integer question, very clear, full marks plus 3, and 0, and in all other cases 0 marks. That means what? There is no negative marking for this. For each question, marks should be awarded in the following categories. So no negative marking. So look, question number 26, very interesting question. TBR6 minus 2. TBR6 minus 2. They are giving TBR6 minus 2, and then BRF2 plus. Then they are saying BRF2 plus, BRF2 plus, BRF2 plus. Then SNF3, SNF3 is a very interesting compound. SNF3, and it is XCF2. XCF2 minus, XCF2 minus, XCF3 minus, XCF3 minus, XCF3 minus. What they are saying, the sum of number of lone pairs of electron each central atom in the following spaces. Very interesting. For example, tellurium, it is coming in oxygen category of the element. That means it is basically tellurium has got basically 6 electrons in the outermost shell, and with minus 2 sign, that means with negative sign, and obviously it is minus 2. So here it is bromine, 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 here it is bromine. So therefore we landed up with 1 lone pair. Here it is 1 lone pair. In case of BRF2 plus, BRF2 is basically 1, 2, 3, 4, 5, 6, 7 is bromine, 1 electron loss is plus, FF. So therefore the lone pair is basically 2. So therefore the total lone pair is 2. In this case SNF3, SNF3 is basically S. It is your basically triple bond N, and it is F. F, central element doesn't have any lone pair. Central element doesn't have lone pair, so therefore it is 0. And then XCF3 minus, if I talk about XCF3 minus, that is 1, 2, 3, 4, 5, 6, 7, 8, and extra electron minus, it is minus, 3 is fluorine, so therefore it is a 1 lone pair, 2 lone pair, 3 lone pair, so 3. So therefore 1 plus 2 plus 0 plus 3 gives you 6. So therefore question number 26 has answer 6. So 6 total lone pairs are available on every compound's central elements. So answer for 26 was 6. And then question number 27, it is an organic chemistry question. Among the following the number of aromatic compounds either are. Very simply, if I talk about cyclooctatetraene, first compound is given cyclooctatetraene. You remember, even though it's showing that it is 4n pi electron, but it is not true, it is not anti-aromatic. It is basically take the top shaped structure, and where the electrons are basically, when the electrons are basically, pi electrons are not in the plane. That means if it is 2pz, 2pz, if it is 2pz, 2pz pi bonds, so it is basically 2p pi, 2p pi bonds, so there is no the conjugation between the pi bond. Number 1, it is a top shaped structure, so therefore it is basically non-aromatic. It is non-aromatic. For example, for your kind of information. So therefore first option cyclooctatetraene is not. Then is second option is given as it is cyclopropenyl. Cyclopropenyl, it is highly anti-aromatic. It is anti-aromatic. It is anti-aromatic. Next, cyclopropenyl cation. Yes, it is aromatic, you know, because it is having 4 into 0 plus 2, that is equal to 4n pi electron, and into C 4n pi electron. 4n pi electron, which gives you 2 pi electron. That means what? 4n plus 2 pi electron. That means 2 pi electron is aromatic. So therefore it is aromatic. Then fourth option is cyclohexamonthridine. It is not at all aromatic. Basically, it is normal aliphatic compound, or we can say olefinic compound, cyclic olefinic compound. Then cycloheptatrienol cation. It is given this is your plus. Yes, it is aromatic. Is 1, 2, 3, 4, 5, 6, 6 pi electron. Follows the category 4n plus 2 pi electron. So therefore Huckel's rule. So therefore it is aromatic, and all the molecules cleaner. So this is again aromatic. Cyclopentadienyl cation. It is not again cyclopentadienyl cation. It is not again. It is again anti-aromatic. It is anti-aromatic. It is anti-aromatic. Cyclopentadienyl amine. Cyclopentadienyl amine. It is obviously aromatic. Everyone knows. Again, I need to say that there is a 4n plus pi electron, and all the lone pair and the pi bond pairs are in the conjugation, so therefore it is aromatic. Then, if I talk about another compound like this compound benzene with another cyclohexene fused, basically. See, it is aromatic because it already has the aromatic ring current, aromatic substrate, that is put plus 2 pi, so it is aromatic. So it is aromatic. And then if I talk about the last compound, kind of phenanthrene, but it is not exactly a phenanthrene. So therefore it is basically, since it has got one at least ring having the pi bond, I mean the conjugation like 4n plus 2 pi electrons, so therefore it is aromatic. 1, 2, yes, it is aromatic. So therefore it is aromatic. So therefore it is also aromatic because already it has got 4n plus 2 pi electron over here. 1, 2, 3, 4, 5. It is also aromatic. Yes, phenanthrene. So it is also aromatic. Yes, phenanthrene. So therefore you can see that 1, 2, 3, 4, 5. So answer choice for 27 will be 5. 5 species aromatic. You can check from the board. 1, it is 2, it is 3, it is basically 4, it is basically 5. So 5 species are aromatic over here. It's very simple question. So so it was a case. Now next. Next question is question number 28. It is a physical chemistry question. It is a simple question basically. A crystalline solid of a pure substance has a first-standard cubic structure with a cell edge of 400 picometer. If the density of the substance in the crystal is 8 gram per centimeter cube, then the number of atoms present in 256 species gram of the crystal is n into 10 to the power 24. The value of n is. I will tell you the way it is basically have to be handled. See, this is the FCC basically. This is the FCC molecule. This is FCC compound, first-standard cubic lattice. Everyone knows, see, this is FCC basically, first-standard cubic lattice. This first-standard cubic lattice. So here, effective number of atoms, effective number of atoms is equal to basically 4 because its contribution is 1 by 8. That multiplied by 8 equal to 1, and the first-standard is half into 6 faces, that is 3, gives you 4 effective number of atoms. So see that I should apply the formula density equal to molecular mass by Avogadro number into number of atoms is basically Z, then Z is nothing but over here 4 divided by A cube. By this formula we'll be able to solve. Here density is given, you should be knowing the units basically properly. Density equal to 8 gram per cc, try to understand. Molecular mass you have to find out because they are given. N is the 6 point, see the approximately you can take 6 into 10 to the power 23. 10 to the 23 into 4 divided by A cube is whatever here given 400 picometer. That means I have to consider in the meter, centimeter. The 400 picometer means 10 to the minus 12 meter. C by 8 centimeter, 10 to the minus 10 centimeter. So it is nothing but whole cube. If you calculate, then molar mass you will be getting the value as the molecular mass you are getting by calculation will be getting as 78.8, approximately 78.8. So once you get molecular mass, so obviously the rest is basically they are asked 256 gram crystal, how many atoms it is possessing. So 256 divided by 78.8 multiplied by, will be getting 278.8 multiplied by this nothing but your 6 into 10 to the power 24. That is 78.8, and it's given as total value is 10 to the power 20. Basically it's coming as 78. So 256 gram, that multiplied by, you can get 17. It will be final value will be 6 into 10 to the power 23. You can write because number of atoms they are asking number of atoms. So obviously what this comes has to be approximately 2 into 10 to the power 24 is coming approximately. You calculate it and check it out. So this is a very simple question. So answer to 28 is basically your 2. Answer is 2. 28 the answer 2. That is basically they are saying now n into 10 to the power 24. That means over here n is basically 2. This is the answer. Next question number 29. That is also a very simple question, I tell you. It is not a difficult question. Question number 29. Question number 29. It is given concentration. Let's say I am talking as monobasic acid, so I can say CH2C. Let's say, for example, I am considering very simple. So obviously it will be giving you CH2C minus plus H plus. It's a very simple example we do it many a times, so therefore it is C into 1 minus alpha, it will be C alpha, C alpha. By that question you can say that it has given pH equal to, pH is given as basically 4. So therefore C alpha given as 4, 4 that is 10 to the power minus 4. So that means what? We can write that alpha will be equal to 10 to the minus 4 divided by, they have given the concentration of the acid is 0.0015, so 15 into 10 to the minus 4, that gives you 1 by 15 is the alpha value. Now, come from the basics once again, what they have said. They have said that the conductivity is remaining, the distance between the electrodes is 120. So if the electrodes distance, suppose it's a cell, and if the electrode is like this, and the conductivity is cell, so the distance between them is basically, they have said 120 centimeter, and the area is basically, where the solution of basically is basically the area of the cross section area equal to basically they have given is basically your 1 centimeter square. That means what we know, R equal to rho into L by A, so 1 by R equal to conductance G equal to kappa into A by L. That's it. So once you get kappa you can easily calculate, because kappa is equal to L. L is what? 120 into conductance they have given. That is 5 into 10 to the minus 7. 5 into 10 to the minus 7. That divided by, they have given area equal to 1. So this is basically your kappa with proper unit. We know the unit of kappa. So once we got the kappa, so now we'll come to this part that they are saying that the conductance of the solution is given. So the value of the limiting molar conductivity lambda for this conduct for this electrolyte. So now look, alpha equal to what? Lambda by lambda naught. Now what is lambda? Lambda is equal to 1000 kappa by C. 1000 kappa by 0.0015. This is the formula basically, and if you put this over here, 1000 into kappa. What is kappa? Kappa is already found. 120 into 10 to the power 5 into 5 into 10 to the minus 7. That divided by 0.0015. From where we are getting the value of lambda, and already we know alpha. Already you know, so you will be getting the lambda naught. That is will be equal to approximately. If you calculate from this, lambda naught will be coming out as 6 into 10 to the power 2 centimeter square mole inverse. So you will get this. So the answer is 6 basically. What means next? Answer is 6. The factor Z is basically 6. That is Z equal to 6. So next question number 30. It is a very simple question. I believe we have done many difficult questions before. So it is a very simple question. So therefore, so this is the answer. Next question number 30. If we talk about question number 30, it is again very simple question on the basis of the MO theory. That is, as you among H2, Hg2 plus so many more species they are given, number of diamagnetic species is. See, H2 obviously is basically, always you apply the MO theory, it is basically, it is all electrons are paired up, so it is diamagnetic, because you can see that by the molecular diagram, the hydrogen has just 2 electrons, so obviously they are paired up, so it is diamagnetic. So they are asking that the number of diamagnetic species, so hydrogen is diamagnetic. Then if you talk about helium plus means what? 1 electron. Helium plus means 1 electron unpaired. 1 electron unpaired, 1 electron lost. So helium plus, basically what sigma we can say 1s1 basically. So this parameter, so it is not diamagnetic. This is diamagnetic. Next, if you talk about lithium Li2 plus Li2 is what? Li2 is again diamagnetic, because in Li2 there is 1s2 the 2s1 basically make the 2s sigma 2s and sigma star 2s, sigma 2s is filled up, so therefore it is diamagnetic once again. Beryllium to Be2 is again, you can check that beryllium basically it is again diamagnetic. Be2 is diamagnetic. If you talk about carbon, before the boron is what? It is basically this. Boron is what? You can say that for boron. This boron atom, just I am taking one example for you. Sigma 2p by 2pz, sigma 2s, 6 pi square 2p by 2pz like this. It is sigma 2s, sigma star 2s. It is pi 2py equal to pi 2pz. That is equal to sigma 2px. It is pi square 2py, pi square 2pz, and it is sigma star 2px. Try to understand that in case of boron, basically 2s2. 2p1, 2s2, 2p1, obviously what these 2 electrons are paired up, and this is 1, so it is paramagnetic, so boron is not diamagnetic, it is a paramagnetic. B2 is not B2 is not diamagnetic, it's paramagnetic. Again, C2 we can say, in case of C2 what happens is that 2 more electrons will come over here, 2 more electrons for this C2, so that will again paired up, so therefore C2 is basically diamagnetic, C2 is diamagnetic, C2 is diamagnetic, and then N2 is again diamagnetic. There is a very famous example, N2 is diamagnetic. You can see, I have shown the diagram, that way also you can show that sigma 2s2, or I can write sigma 1s2, sigma star 1s2, sigma 2s2, less sigma 2px, sigma 2p y2, sorry, pi 2p y2 equal to pi 2p z2, pi 2p z2, then sigma 2s 2px2, 2px2, then pi 2p y pi star, then pi star 2py 2, and that's equal to pi star 2pz2. So in total, nitrogen has got 7 electrons, so total 14, 2 to 4 to 6 to 8 to 10 to 12 to 2 to 4 to 6 to 8 to 10 to 12 to 14, 14, and then nitrogen is 1s2, 2s2, 2p3, 1s2, 2s2, 2p3. So yes, that means it is 2p1, 2p1, right? 2p1, 2p1. So therefore, it is basically your paramagnetic. Nitrogen is paramagnetic. Nitrogen is basically what? Nitrogen, you can just take it out. 2p3, it is nitrogen. Let's say it is nitrogen. It is a nitrogen. Look over here. 2s2, 2p3. So then 2 to 4 to 6 to 8 to 10 to 12. Yes. 3 to 3. 3 to 6 to 8, 3 to 6 to 8 to 10, 2, 4, 6, 7, I'm so sorry, it's not going to anti-bonding even, it is on the bonding, 2 to 4 to 6, yes. So therefore we will get over here, biaxial 2p is not there, actually not referred, it is total, it is basically your 10 electron, so therefore N2 is basically diamagnetic, N2 is diamagnetic. Because it is basically, I have not taken 1s2, you can take 1s2 also, the sigma star 1s, the sigma 1s2 like this, the sigma star 1s, it is sigma 1s and it is 2 electrons each, so therefore sigma 1s2, sigma star 1s2, then sigma 2s2, sigma star 2s2, then pi 2p y2, pi 2p z2, and then sigma 2p, sigma 2px2. So therefore you can get it as diamagnetic, and then O2 minus, obviously if O2 definitely O2 is paramagnetic, so O2 minus is also paramagnetic, one electron will be unpaired in MO diagram you see, and F2 obviously will be diamagnetic. So therefore F2, because 7 and 4 electrons are paired, just now we shown in the previous example that pi star 2p and pi star 2pz are having two electrons each, only sigma star 2px, which is basically LUMO, which is unfilled. So therefore F2 is also diamagnetic. So therefore hydrogen, H2, Li2, Be2, C2, N2 and F2. So in total 6 is the answer. Single digit question 6 in the answer. So question number 30, the answer will be equal to 6. In the question number 30, the answer will be equal to 6. Next, if we go to question number 31, if we go to question number 31, if you go to question number 31, we go to question number 31. For the given orbital, the question is that they have given the wave function chi at NLF is a mechanical function whose value depends upon spherical polar coordinates r theta phi of the electron and characterized by the quantum numbers a, L and ml, where r the distance on nucleus, it is co-latitude and phi is azimuth. In the mathematical function given table Z is given and this is the bow radius. For your time information, I uploaded one of my video lectures on YouTube by the name, my name is AMITAVA Mazumder. That is, I uploaded one video that is Schrödinger wave equation, or rather wave mechanics applied to define shapes of atomic orbitals by AMITAVA Mazumder. Same thing I discussed there. You can see long before I upload this particular YouTube lecture on Schrödinger, it has come over here. Just look at over here, 31. They are saying for the given, whatever the active columns are there, you understand? One is orbital, the chi, and then the graph like that. The question of 31, for the given orbital in column 1, the only correct combination for any hydrogen-like spaces. So answer obviously my hand goes to B, because see B in the B, 2s orbital. B is basically 2s orbital. What is 2s orbital? 2s orbital is matched with basically, we can say 2, that is 1 radial orbital. Obviously, for this we know it is 2s orbital radial. It is basically 4 pi r square, 4 pi r square, psi square r dr into, or you can say r square r dr versus r is the nucleus. So only one nodal can be made, and that value particular is 0.52 angstrom. This one nodal point we get, and the plane passing through the nodal point is the nodal plane. So therefore, one nodal plane we get for 2s. So therefore, obviously, we can say that we can say 2 in the left side. The 2 is basically matching, and then they are saying that in a graph basically it is given as RR graph. Basically, it is a RR graph, or you can say psi R graph, or RR, what you call is equal to RR graph, or you can say R, and for this it is basically like this for 2s graph. So for this 2s, this is graph is like this, so therefore P. So this will be the answer. So 31 answer will be. So I gave this particular concept long before on YouTube. You can check it out. Wave mechanics applied to define shapes of atomic orbitals, where I discussed Schrodinger equation. My name is AMITAVA Mazumder. Question number 32. Again, if you check out question number 32. Question number 32. And that for helium plus ion, only the incorrect combination is for helium plus ion. Just think of helium plus ion. What sort of species this is? Helium plus is making monoelectronic species. It is more hydrogen-like species. Helium plus. So it will behave like it can follow the Schrodinger wave equation. Now only incorrect option. My hand goes to basically C. Why? Because just look at 1. If I talk about 1s orbital. If I take 1, that is 1s orbital. 1s orbital, and with that, if I take 3. If I take 3, then it is basically psi. If I take 3, then we are getting psi. And clearly, in the psi function, they have been function of theta. They have mentioned it cannot be theta because s orbital does not depend on theta phi. It only depends on r, radial distance only. It is spherical. Basically, it is spherical in shape. So theta or phi cannot be there with r in the distribution. So therefore, already we have come to the conclusion that C will be the answer for 32. Now if I talk about 33, for hydrogen atom, the only correct combination can be, say, 1s orbital. My hand also goes to basically A. You know why? Because 1s orbital, 1 is basically, you see that 1s is correct option. They are saying 1s orbital, and then 1 is basically C. In 1, you get the function of only R. So beautiful. There is no theta phi. So naturally 1 is correct, and obviously S. If you see the S, energy used to excite electron when equal to 2 equal to 4. 27 method, you can just Bohr's theory can apply. That is the S option. You have to just apply Bohr theory and you will get the answer. So therefore, this is the conclusion that 33 correct choice is A. 33 correct choice is A. Next, wonderful, another organic question is given. That is 34, let's say. See, normally master column between 2 column happens, it is a 3 column cases. So very interesting. For the synthesis of benzoic acid, the only correct combination. See, they are saying that only correct combination, let's say we are talking about benzoic acid. See, we have to produce benzoic acid. Now how can benzoic acid can be produced from the whole 4 options? Toluene, yes it can give, acetophenone, yes it can give, benzyl it can give, phenol cannot give. Now if I say out of ABC, which one is correct? If I say the combination, if I say the acetophenone combination, yes. If I take the acetophenone combination, that's a CO, CH3, with this, that is your acetophenone is 2 basically, acetophenone with this bromine in a way. Simply a haloform reaction. So you get this plus CH3, C double minus. You get CH3, C double minus. So therefore, yes, you get benzoic acid. It is a haloform reaction, and choices there. Yes, in the column 3, there is a haloform. So S. So it is S basically haloform reaction. So quite naturally. So your answer 34 will be your D. That is combination of acetophenone, bromine innovate, and haloform reaction. That is the answer. Next question number 35. Question number, very simple question. I don't know in paper 2 what they will give, but still now this is very easy. The only kind in which the reaction process to radical mechanism. Radical mechanism, we know free radical mechanism can happen with photohallucination. It can happen with the mechanism NBS and bromosuccinimide. It can happen with sulfuryl chloride with organic peroxide. Also, you have seen the vertical reaction in this thing your anti-Marconi there is a Kharas effect, anti-Marconi there is so many places you have seen that vertical substitution happens. So over here it is basically we can start with toluene, yes toluene, and if I give that is toluene is coming as 1, that is 1 column 1 1, and then if I take the combination of number 2 Br2H nu, number 2 it is your Br2H nu, yes Br2H nu will give you what? They will give you what? CH2Br. CH2Br, obviously we know that is basically, if I say one equivalent, then it is better. Bromine H will give you what this, and the mechanism is very simple. If you see, bromine basically first kept down or breaks down by H nu to Br dot. We know that this is a homolytic cleavage. It is a chain initiation, and then chain propagation happens with bromine dot plus toluene CH2H. There is a H and Br will be going form HBr, and then benzyl radical, and this will go on. This will also react with again bromine molecule to give you bromine benzyl bromide CH2Br. So obviously that is your plus bromine dot. So obviously it's a free radical substitution. Hydrogen being substituted, one hydrogen with toluene's one hydrogen is free radically substituted by bromine atom. Over here it is bromine atom. So there is a free radical substitution. So therefore, in this question number 35, the answer choice will be A. So combination again I will repeat. That is your toluene, column 1 1, then column 2 bromine nu, and column 3 basically substitution is out. So this is the answer. Next question number 36. Question number 36. Last question. Question number 36. It is again given the only correct combination that gives two different carboxylic acids is. Very interesting. Two different carboxylic acids. That means you need to get two different carboxylic acids. So it is very famous reaction. Everybody knows there are three reactions important in aldehyde condensation and in carbonyl compounds. There is aldehyde period. One is aldehyde condensation. Second is cannidal reaction. Third is Parkin's condensation. So obviously, if I talk about acetic anhydride, it immediately comes into my mind double bond CH3. I will show the mechanism of this reaction. Then basically your, if you give CH3 C double minus, CH3 C double minus, and it is given K plus, yes K plus, and obviously heat should be given. So you get cinnamic acid CH double bond CH C double OH. There is cis compound and it's a trans compound, and also you get cis variety also CH double bond CH C double H. So this is variety. So you get both the compounds as a whole. So therefore this is basically the answer. So answer choice will be 36. Answer choice will be B. That means combination is basically 3 and then your 3 and then P. P means condensation, yes. So it is condensation reaction. For your information, if you have time, you can see that the mechanism is very wonderful, interesting mechanism in Parkin's. I will give you an added to you, that is acetic anhydride CH2C double bond O. I am writing the mechanism of Parkin reaction or Parkin's condensation. Parkin condensation, very famous reaction. O, that is O, C double bond O, it is CH3, that is CH3 means H. I will give CH2C double minus, then after the hydrogen to take the carbon, so therefore we get CH2 minus, C double bond O, it is O, C double bond O, CH3, and then it will react with benzaldehyde, PHCHO, benzaldehyde, this carbon will attack over here, it will open up, so you get what? That is like this pH, that is the O minus, that is like this, PHCH2.